Good evening, friends. Study with Apala Engineering and General Geology Parvin Singha. So, in chapter 11, mica group. Journal. Minerals of mica group are characterized with the presence of a micaceous structure, cleavage, by vitreous, of which these can be split into very thin sheet along one direction. So, this micaceous cleavage is explained by their atomic constitutions. They consist of a SiO4 a silicate structure, tetrahedral linked at 3 of cleavage is explained by their atomic constitutions. They consist of SiO4 tetrahedral linked at 3 of their corners and extending in 2 dimensions. This is called the sheet structure. These sheets are held together in pairs of metallic ions. Examples: potassium ion in muscovite, magnesium iron ions in biotite. But the bond or resulting due to the metallic ions is the weakest, and hence there is an eminent cleavage present in the micas. And mica are, besides feldspar, pyroxene and phibbles, very common rock forming minerals, forming approximately 4% of the crust of the earth. And despite great variation in their chemical composition, mica minerals are easily grouped together because of their similar atomic structure. Chemical compositions. Mica group of minerals show a great variation in their chemical compositions, and broadly speaking, they are mainly silicates of aluminum and potassium containing one or more of hydroxyl group, magnesiums, iron, sodiums, lithiums, and fluorine. Because of almost invariable presence of a hydroxyl group, all the micas yield water when heated in a closed test tube. In view of a very complex chemical composition, the formula given for different mica minerals should be considered only approximate. Atomic structure. As mentioned above, mica are characterized with a sheet structure in atomic constitution. In in this type of structure, the basic unit of silicates and SiO4 tetrahedrals are linked at all their 3 corners. Oxygen ions resulting in silica and oxygen ratios is 2:5, and such a linkage when extended in 2 directions resulted in sheet of SiO4 tetrahedrals. To such sheets are so placed one above another that their vertices point inwards towards each other. In it is there that they are mutually cross-linked with a metallic ions, commonly aluminiums or magnesiums. Other groups, especially the hydroxyl groups, are also incorporated in between these cross-linked crystallizations. Most important member of the mica groups crystallize in one system only is monoclinic system. Some less important members of crystallize in the triclinic system. It is a typical of mica crystals that apparently they show a higher symmetry as if they were belonging to orthorhombic or hexagonal systems. The crystals show prism along angles of 60° and 120° because of atomic constitution. Micas show excellent basal cleavage. A 6-rate percussion figures is sometimes obtained when the cleavage plate of mica is struck at with blunt pointed tools. The lines which is most distinct in this figure is parallel to 010 phase. Classifications. Micas are generally divided into 2 groups based on their chemical composition and hence colors: light mica and dark mica. Light mica muscovite, Kl2 AlSi 2 O10 whole OH whole twice potass mica. In other words, paragonite, sodium aluminum NaAl2 AlSi3 O10 whole OH whole twice and sodium micas. Lepidolite Kli Al Si4 O10 OH whole twice lithium micas. Dark micas biotite K, MgFe whole thrice, AlSi3O10, which whole twice iron magnesium mica. Phlogopite, potassium magnesium K, KMg3, Al3, Si3O10, OH whole twice, magnesium mica. Zinc weldite, complex lithium iron micas. Physical properties. Among the properties that are common to all the minerals of the mica groups are perfect basal cleavage, low hardness between 2 to 3, vitreous, luscious and platy habits of the crystals. Descriptions. Descriptive value, importance, descriptions about in detail. From among the mica groups, only muscovite and biotites are of a common occurrence as rock forming minerals. Muscovite KAl2, AlSi2O10, which whole twice potass mica. Crystal systems monoclinic commonly occur in platy forms which is pseudo symmetry of hexagonals or orthorhombic types. Cleavage eminent basal 001s. Colorless in thin sheets as a mass may appear pale yellow. Hardness 2.5 to 3.0, so specific gravity 2.7 to 3.1. So luster pearly on cleavage faces vitreous. Streak colorless. Optically negative. Occurrence, it is the most common variety of all the micas and occur in abundance in acidic igneous rocks such as the granite and pegmatites, and also in metamorphic rocks. Mica schist. It is a common accessory minerals of sedimentary rocks. Varieties. Muscovite is a good electrical insulators and finds extensive use in electrical industries and for making fine proof materials. Biotite KMgFe whole thrice, AlSi3O10, OH whole thrice, black mica. Crystal systems monoclinic commonly occur in tabular sheet or short prismatic plate. Cleavage highly perfect and basal. The colors black, deep green variety is also found. Hardness 2.5 to 3. Specific gravity 2.7 to 3.1 increased with iron content. Streak colorless. Optical property optically negative, strongly paleochroic in thin sections under microscope. Occurrence commonly found in igneous rocks and metamorphic rocks like gneiss. It is rare in sedimentary rock compared with muscovites. Phlogopite, in other words. KMg3, Al3, Si3O10 whole, which whole twice. It is a monoclinic types of mineral, mica, and rather limited in occurrence and confined to crystalline limestones and dolomite. Color, yellow, browns and red. Hardness 2.5 to 3. Specific gravity 2.7 to 2.85. Lepidolite, KLI means Li indicate lithiums. Okay. KLI, Al, alumina, Si4, O10 whole, OH whole twice. This mica commonly occur in the forms of a granular mass and show the typical properties of mica. Perfect cleavage, hardness 2.5 to 4, specific gravity 2.8 to 3.3, and pearly luster. It is the occurrence. In its occurrence, lepidolite is confined mostly to igneous rock, especially to pegmatites. It is important as a source of lithium. Thank you.